Okay, so in the previous clip, we looked at an atom of sodium as our example, and we evaluated that that had 11 protons, 11 electrons, and subsequently 12 neutrons based upon the numbers given in the periodic table within the elemental symbol. And what we're now going to do is take these particles and essentially place them into the atom of sodium. Now, two of them are relatively straightforward to place because we place them into the nucleus being a small, high density region of the atom where the vast majority of the mass is contained, and that is where the neutrons and protons are contained within that nucleus. So the nucleus has a 11 positive charge due to the protons there, and the 12 neutrons also contained within that small region of space. The more detailed look, though, is then required at the electrons because we now know, based on the nuclear model, that the electrons exist in energy shells, energy orbitals, rings around the outside of the nucleus. And what we need to look at are the rules in which we build up the atom using the number of electrons that we have in order to complete the shell, the outer shells of sodium, in this example, sodium atom. So we know we have 11 electrons. So we start filling from the innermost shell first. The protons, the positive charge, pulls those electrons into the closest possible shell. Now, the smallest shell is obviously the one in the middle, and that can only contain 2 electrons. Any other electrons have to then be placed in subsequent shells. So we've used up 2, we have 9 electrons left, and essentially we start to fill up the outer shell, the second shell of sodium. Now, this second shell is slightly larger and has the ability to take 8 electrons. I tend to draw them in pairs because it makes some of the subsequent diagrams we're going to look at easier to draw if you've kind of got 90-degree angles within there, but also it makes it easier to count the 8 electrons, I personally believe. So we've now used 10 electrons, which means we've got 1 electron left. And as we said, the subsequent shells, especially the second and third shells, can only contain 8 electrons. We've now got 1 electron left, and so this goes into that third shell. And what we've now done is built up an electronic configuration of sodium, whereby we have 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third, the outermost shell. And you may see them either as diagrammatical dot cross diagrams. We've drawn these as dots, but you may also see them as crosses, as electrons as well. Both of them are interchangeable in the sense of it's not wrong to draw with either, but when we start looking at bonding diagrams in further clips, it makes sense to try to be consistent with what you do so you can see where electrons start at life and where they end up when we go through things such as ionic and covalent bonding. And in the clips carrying on from here directly, what we're going to look at is how this electron configuration, specifically how the outer shell electron interacts and gives us rise to things such as valency and the ability for sodium, for example, to undergo ionic bonding and subsequent things from there.